Hello everyone and welcome back. I am Mr. Cobalt and today we are going to be talking about converting between mass and number of particles. So in the last couple of videos I showed you how to convert from moles and particles using the Avogadro's number 6.022 times 10 to the 23rd because we know that 1 mole is equal to that number. In the last video, I showed you how to convert between mass in grams and moles using the molar mass. Now we're going to put those two together and we're going to convert between the mass in grams and the number of particles. So I have a couple of problems that we're going to work over and you'll see how it's done. So the last time it was one-step problems, now we're doing two-step problems. Okay, so our first problem is how many copper atoms are in a copper penny with a mass of 3.10 grams. Now, for this, we're going to assume that we have pure copper penny, so there's nothing in it but copper. Okay, so how do we do this? So you have to figure out where to begin and where to end, and that is almost always going to be found in the question itself. So the beginning of the question usually tells you where to end. How many copper atoms? So we want to end at particles, at atoms. So we're going to end at atoms. Where are we going to start? Well, we got to keep reading. How many copper atoms are in a copper penny with a mass of 3.10 grams? So we need to go from grams to number of copper penny or copper atoms. So we're going to start with what they gave us, 3.10 grams. We're assuming that this is pure copper, so we've got copper. So this is 3.10 grams of copper over 1. And then we got to start converting. So to figure out what comes next, we look at what's on top, grams of copper. So whatever is on top, it's got to go on the bottom. That is a non-negotiable because we need to start somewhere. And since we have grams, we need to get rid of grams. So we're going to put grams of copper on the bottom. So now we need a conversion factor that is related to grams. Okay, so we know about molar mass. So we know that molar mass relates a certain number of grams to a mole. So we can convert from grams to moles using molar mass. So we look in our periodic table for copper. Copper has a molar mass of 63.55. So 63.55 grams for every 1 mole. So that grams goes on the bottom. 1 mole of copper goes on top. So grams of copper cancel out. Now I have moles of copper. So I made one conversion. They are asking for atoms of copper. I have moles. So I'm not done. So I need another conversion. So I write another step. And now I need to go from moles to atoms. So I need to go from moles to particles. That is Avogadro's number. 1 mole is equal to 6.022 times 10 to the 23rd. So I'm going to put moles on the bottom because I have moles up top. So 1 mole of copper is going to be equal to 6.022 times 10 to the 23rd atoms of copper. So moles of copper cancel out. I'm left with atoms of copper on the top. Atoms of copper is what I want. I am now done. So now all I need to do is calculate. So I grab my calculator and I'm going to multiply and divide. I'm going to multiply across the top, divide by the bottom. So I have 3.10 times 6.022 times 10 to the 23rd divided by 63.55 equals, and I get 2.9375. So 2.9375 times 10 to the 22nd. So times, let me do that, times 10 to the 22nd atoms of copper. So once again, I have to check my sig figs. So I'm only allowed the least number of sig figs in my answer. So here I have 4, here I have 4, here I have 3. So the least number is 3. So my answer can only be 3. So I'm going to cut it off here. So 2.93. I have a 7 there, so that goes to a 4. So my final answer is 2.94 times 10 to the 22nd atoms of copper. So this is my final answer. All right, is that clear? I hope so. The next problem. Now in the next problem it's saying calculate the mass of 2.25 times 10 to the 22nd tungsten atoms. So again, not a question, but it's telling me what they want. They want the mass. So they want me to calculate the mass, grams. They don't specify unit, so we'll just do grams. Calculate the mass in grams of this many tungsten atoms. So we're starting with particles and we want to get to mass in grams. So we start with what they gave us. So we start with 2.25 times 10 to the 22nd tungsten atoms. Okay, capital W is the symbol for tungsten. I'm going to put that over 1. So I'm going to do my first conversion. Since they gave me particles, atoms of tungsten, I need to have particles on the bottom. So atoms of tungsten. So atoms of tungsten. And now I need to go from particles to something. Well, if I know Avogadro's number, I know that that's the number of particles in a mole. So I can convert from particles to moles, or atoms, in this case, to moles using Avogadro's number. So I'm going to put Avogadro's number on the bottom, 6.022 times 10 to the 23rd. And then 1 mole goes on top. So 1 mole of tungsten on top. So atoms of tungsten cancel out. Now I have moles. They are asking for mass, grams. I don't have grams, so I need another conversion. So I keep using conversion factors until I get the unit I want on top. So I need another conversion. So now I have moles, but I need grams. So I need a relationship between grams and moles. That's the molar mass. So I need the molar mass of tungsten. So I look up the atomic mass, which is the same thing. So I'm going to look up tungsten in my periodic table. Where are you, tungsten? Looking for a capital W. I know you're somewhere. Where are you? Oh, there you are, number 74, 183.84. So 183.84, 183.84. So that means that for 1 mole of tungsten, I have 183.84 grams of tungsten. So notice I put moles of tungsten on the bottom to cancel out with it on top, and I put the molar mass, the grams, on top. So moles of tungsten cancel out. I'm left with the mass in grams. The mass is what they're asking for. I am done. So now all I need to do is calculate. So I'm going to grab my calculator. I'm going to multiply across the top, divide by the bottom. Okay, let's try this out. I have 2.25 times 10 to the 22nd multiplied by 183.84 divided by Avogadro's number 6.022 times 10 to the 23rd equals, and I get a mass of 6.86. So that's going to be 6.8688, I believe. 8688. This is grams of tungsten. So now I need to make sure that I have the right number of significant figures. So my answer again can only be in the least number of sig figs. So here I have 4, here I have 5, and here I have 3. 3 is the least, so I can only have 3. 6, 8, 6. So I'm going to cut it off at the 6. I have an 8 here, so we round that to a 7. So my final answer is 6.87 grams of tungsten. So that is how you convert between number of particles and mass. Each time it's going to be a two-step problem. If I'm going from grams to particles, then I first use the molar mass to convert grams to moles, and then I use Avogadro's number to convert from moles to particles. If I'm going the other way, then I'm switching the conversion factors around. So here I'm starting with atoms. So to convert atoms to moles, I use Avogadro's number. And then to convert moles to grams, I use the molar mass of the substance I am interested in. Okay, so I hope this was helpful. If you liked it, go ahead and like the video, share the video, make a comment in the comment section, subscribe to the channel, ring the bell for other notifications. Thanks for joining me, and I'll see you next time.